In this video, I merely want to go through a number of examples where we are integrating trigonometric functions. Now, the examples and notes that I have placed on the Moodle site is self-evident in a number of different ways. It is trigonometric functions that you are quite familiar with, and it's merely merging the basic integral of sine and cos together with corresponding identities and then integrating that using a number of your integration techniques. So even though these examples that I'm going to discuss right now are not specifically the cases that you see in the notes, these are supplementary, and the explanation that will be delivered in this lecture, in this video, will be sufficient for you to understand the notes. So let's have a look at the first one. The integral of sine squared of 3x dx. Now, in this case, do not be tempted. It is so tempting. And once again, I'm not going to indicate the temptation. Just be aware that this is a sine function that is raised to the power 2. So it is sine squared of 3x. Now let's consider sine squared itself. So sine squared of x. We know that cos squared of x plus sine squared of x is equal to 1. We're also aware of the double angle of cos 2x. Cos 2x is equal to 1 minus 2 sine squared of x. Now, in this particular case, notice that the index is an even index. And with an even index, we tend to use this form after we have transposed and worked out the 2 divided by 2, and then we obtain, as I've indicated on the notes, sine squared is equal to a half multiplied by 1 minus the cos of 2x. So these are our double angle identities, merely reformed variations of the double angle identities. Now, why are they double angles? You can look at it in a number of ways. That's sine squared of x. That's cos of 2x. That's double the angle that you see here. Or another way, this x over here is half of that angle that you see there. Therefore, what is sine squared of 2x? You will merely double that to 4x, because this must be a half of that, whichever way you look at it. 4x is double 2x. 2x is a half of 4x. Therefore, nothing else changes. Sine squared of 3x will be a half of what? 1 minus cos of? That's right. And that is the identity you will use when you get an even index. And all you have to do now is substitute. So that will be the integral of a half times 1 minus cos of 6x dx. And whichever way you want to do this, you want to integrate separately. A half. What is the integral of 1? That is x. What is the integral of cos of 6x? It's minus sine of 6x divided by 6 plus my constant c. That's your answer. Nothing much to that. Now, since we have space here, I'm going to look at the integral. Let's just consider what we integrated. We integrated the 1, we know that's x, that's fine. What about the cos 6x? What is the integral of cos of 6x dx? Well, we know that the integral of cos of x by itself, in other words, when it's a coefficient of 1, is simply sine of x plus the cos, plus your constant c. What about cos of 6x? Well, to do this the long way, you're going to introduce u, let 6x equal to u. You're going to find du, the derivative of 6x is equal to 6. You're going to substitute for dx like we did with u substitution. But at this stage of integration, you should be able to do that visually without having to do long u substitution. In other words, as soon as this is not the standard 1x, then you make that u mentally, let it equal to u. Then find its derivative. What's the derivative? 6x. Of 6x, sorry, it's 6. But outside of cos of 6x, you don't see 6 at all. But you would like to insert the 6. And you can do this. However, if you do insert that, because it will give you 60x, then you compensate by putting 1/6 outside. Because that 6 will neutralize that 6. It will cancel off. But why do we want to do that? So we can do this. So we can say, listen, I made that u. Therefore, the du is 6 dx. And you can verify that the long way. And therefore, your answer will simply be 1/6. What is the integral of cos of 6? Sine of 6x. And there's your answer. As simple as that. The integral of cos u is sine of u. Sine of u, and we made u 6x, compensated with the 6, which gives you the answer you see there, sine of 6x divided by 6. Now, what I have done here, you should be able to do that mentally. In other words, you should be able to write that answer immediately. U substitution is basic. It's basic integration techniques. Let's look at another example, also with our trigonometry. The integral of 0 to pi over 2 sine squared of x cos squared of x dx. Now, once again, this is totally different to what you've seen in the notes. In the notes, I had only a even power or an odd power. Or for that matter, I had an example of this nature, sine 3t cos 2t dt. And you must be able to recognize this as a product. If you go to the notes, you'll see there are identities that you will use. We'll get to this just now. Let's just return. What do I do in this case? Integral of 0 to pi over 2, a definite integral, sine squared of x times cos squared of x dx. Think about that carefully. This is where your understanding of u substitution comes in. Sorry, I'm going to correct this because this is incorrect. Cos cubed x dx. And there's other variations. It could be sine squared, cos squared. It could be sine squared cos to the power 4x or the other way round. Nonetheless, how do we go about finding this integral? And this is where your knowledge of those two identities that I've indicated in the notes. The one is the square identity and the other is the double angle identity. Now, in our first example, we looked at a double angle identity. In this case, we are going to use a square identity. Now, if we're going to use a square identity, we need squares. We already have sine squared of x. If we made that sine squared of x, let's just do that. Imagine I made sine squared 1 minus cos squared of x, and I left cos cubed x dx. And then I multiplied out, and I get an integral, the integral of cos cubed of x dx minus integral of cos to the power 5x dx. I certainly can do this the long way. Then I will use, in both cases, the odd power rule. And once again, I'm going to say this, and I hope no one's thinking not be tempted. This is an integral to the power 3. It's not x cubed. It's not u cubed du. It's cos cubed. So you can't do anything as it stands, like adding 1 and then dividing. You can't do that for the integral. You have to look at identities. So what will we do in this case? We could possibly continue further, but very lengthy. Well, let's go to what we had, in fact, done with odd powers. Let's leave the even power and take that and separate it into cos squared times cos of x dx. Now, why would I want to do that? Because now I can use this identity, and that becomes the integral 0 to pi over 2 sine squared of x. What's cos squared? 1 minus sine squared of x times cos of x dx. Remove the brackets. Sine squared times 1 sine squared of x, sine squared times minus sine squared, minus sine to the power 4x, and they are all multiplied by cos of x dx. And once again, it's noticing u substitution, that the one is the derivative of the other. To make it, I hope I'm going to be making it easier, this becomes 0 pi over 2, and let's remove these brackets. I'm going to get sine squared of x cos of x minus sine to the power 4 of x cos of x dx. Now, how do I integrate sine squared cos of x? Well, it's simple. Because sine is a higher power, you make that equal to u. And just like I explained in the previous example, how you could look at it and say, well, if this is u, if sine is u, then but the derivative of sine is du. And because sine is squared, it becomes u squared. And now you simply have to integrate u squared to give you u to the power 3 over 3. And what is u in this case? Sine of x. And we do likewise over here. This is u to the power 4, and that's my du. And with that knowledge, I can now write down my solution. Integrate sine squared of x, u squared, add 1, u to the power 3 over 3. What is u? Sine cubed x, divide by 3 for that one, minus, what would this give you? Integrate that. u to the power, add 1, 5 over 5. What is u? Sine to the power of 5, x over 5. And this is a definite integral going from 0 to pi over 2. And we know what to do in this case. Substitute sine cubed pi over 2 over 3 minus sine to the power of 5 pi over 2 over 5. There's your upper limit. Subtract the lower limit. And of course, sine of 0 is 0. So that will give me 0 minus 0. Sine of pi over 2, 1 cubed, 1/3 minus 1/5. That gives me an answer of 2 over 15. Example 2. Example 3, and the last example. Now this particular one is, once again, go to the notes. Products of sines and cosines. And in order for you to solve these, they are possibly the easiest, provided you identify the correct identity to use. And in this case, it's a sine and a cos. And that's my A and my B. And using the appropriate identity, look at those identities in the notes. It's a half of sine of the A, which is 3t, plus the B, 2t, plus the sine of 3t minus 2t dt. And integrating that, I get a half of the sine of 5t plus 3t minus 2t dt. And using your visualization of u substitution, you can write down the answer immediately. That is a half. The integral of sine is minus cos of 5t, compensate with the 5 minus cos of t plus my constant. And of course, that is your final answer, minus cos of 5t over 10 minus a half cos of t plus my constant c. That's using the formula for the products of sines and cosines. That is a short lesson on trig and brings that to a close.